Okay, continuing with our videos, we will look at determining if a sequence is arithmetic, geometric, or neither, and writing a formula in terms of n for our particular sequence. All right, so we look to our first one, and we see that each time we're subtracting 8, and so we know that we're arithmetic, right, with the common difference of -8. And so therefore my nth term is going to be equal to -8n plus 23. Right, how did I get 23? Well, 23 minus 8 is equal to 15, and if I start my counter at n equals 1, things work out. Right, if I look to the next one, my numerator seems to increase by 1 each time. My denominator seems to be cubes. If I look, 1, 8, 27, 64. So I know that this is neither because we have no common ratio. We have no common difference. And my nth term, it looks to be that the numerator is going to be n plus 1, and the denominator is going to be n cubed. And so I want to make sure that it looks like I have n cubed, and there we have it. For this last one, looks to be that I have a common ratio. All right, looks like I'm multiplying by -1/2 each time. All right, so we have a common ratio, r is equal to -1/2. That means that I am geometric, and that means that my nth term is going to be my first term times my common ratio, n minus 1. And there we have it. Okay. Find a formula for use of k in terms of k. State whether the sequence is arithmetic, geometric, or neither. So slightly different approach, but similar ideas. 2 to 6 to 18 to 54. All right, we have that we have a common ratio is equal to 3. Therefore, we know we're geometric. And our kth term, all right, so we'll say u sub k is going to be equal to, if I'm geometric, it's going to be 2 times my common ratio raised to my counter minus 1. All right, if I look to the next three, 3.54, 4.5, so this seems to be that I have a common difference of 1/2. That means that I am arithmetic. And my kth term is going to be my common difference times my counter. All right, make sure your counter matches your counter. So 1/2 k, and then I need to figure out what is going to get me to my first term. If k is equal to 1, that's going to be 2.5. All right, if I look to the next, right, do I have a common ratio? Let's see. Well, what's 16 divided by 9? Okay, what's 25 divided by 16? I don't have a common ratio. But if I look at my details a little bit more, I seem to recognize that these are perfect squares, right? So because I recognize that these are perfect squares, I can say that my kth term is going to be k plus 2 quantity squared, right? So if k is equal to 1, I'm going to have 1 plus 2 quantity squared, then 2 plus 2 quantity squared. If I didn't recognize that it was perfect squares right off the bat, what I could have also done is said, hey, what are my differences? And if I look to my differences, because I didn't have a common ratio, I can see that my second differences are going to be constant, so I know I'm going to have something related to a square. And in this case, it's just going to be k plus 2 quantity squared. All right, if I want to figure out the indicated term of the sequence from the given information, I can set up with determining the ratio if I'm geometric, determining the common difference if I am arithmetic. Okay, so I know that r squared, my common ratio squared, is going to be 64 over 27. Whoops, let's make sure I write that correctly. 64 over 27, all divided by 16 over 3. So I know that my ratio squared is going to be 4/9. Okay. So my ratio squared is going to be 4/9. That means that my ratio could be plus or minus 2/3. Okay. Let's assume that we have all positive terms and we're going to use the positive ratio. So let's say that we know that we're going to have positive terms. Okay. So that means that my given term, all right, my nth term is going to be my first term. Well, I don't know my first term. Well, I could figure it out, but it doesn't say I need it. I just need to figure out the seventh term. Well, I know that my fifth term times my ratio squared will give me my seventh term. So being alternating or not doesn't actually matter here. So I don't need to worry about having positive terms because I want the seventh term. And so I'm going to have that 64 over 27, right? That's the fifth term, times my ratio squared. My ratio squared was 4 over 9. And that's going to give me the seventh term, which is 256 all over 243. Okay. Now, if I look to see, I could recognize a pattern in looking at my work and say, oh, hey, wait a second. I can kind of tell the pattern that the numerator is going to be based on squares of 2, right? And the denominator is going to be based on squares of 3, and just figure out, hey, 2 to the what power, 3 to what power, but not going to worry about that at the moment. All right, we want the third term arithmetic sequence, and I have this setup. Well, what is 61 minus 25? Because we know we're looking for differences. That's 36, right? What's 20 minus 8? That's 12. So I know 12 differences is going to be equal to 36. That means one difference is going to be equal to 3. I want my third term. Well, my third term is simply going to be my eighth term minus 5 differences. Right? I don't need to figure out my first term. I just need the relationship between them. Okay, so my eighth term is 25 minus 5 times 3, and that's going to give me 10. So I know 10 is going to be my third term. I could double check. Right? That's the third term. Plus 3, fourth term. Plus 3, fifth term. Plus 3, sixth term. Plus 3, seventh term. Plus 3, eighth term. And so I can see that it does work. Understanding this relationship, right, between terms, whether you're arithmetic or whether you are geometric, is very, very important to simplifying your work. Okay, continuing, we have a sequence of positive 4-digit integers ending in 7. State the first 3 terms. So I have a 4-digit integer ending in 7. So the first one will be 1007, right? Then I'd have 100, well, not 100, 1017, then 1027, right? And going on. I want a general formula for the nth term, u sub n. So u sub n, I could think of as being, let's see here, I would have, let's see, common difference of 10. So I could say that I'm going to have 10n plus 997. Okay. Then I want the first, second, and third partial sums. The sum of the first term, well, that's just the first term. That's 1007. The sum of the first 2 terms, that's going to be, right, 1007 plus 1017, which is 2024. The sum of the first 3 terms is just going to be the sum of the first 2 terms plus that third term. Right, so I have the sum of first two plus the third term, 1027, and that's going to be 3051. So I've got 3051, I've got 2024, and I have 1007. All right, for number 10, use an appropriate formula to find the sum of the first 10 terms of the series. So I want 10 terms, so I have to figure out what's happening here. It looks to be that I have a common ratio of 1/3. That means that I'm geometric. I have a first term equal to 1, and I know that the sum of the first 10 of a geometric series is going to be 1 times 1 minus my ratio to the 10th power all over 1 minus my ratio. Okay, so I'm going to have 1/3 raised to the 10th power. I'm going to have 1 minus that number, and I'm going to take that and divide it by 1 minus 1/3. And that'll give me my summation, which seems to be, let's see here, 29,524 all over 19,683, which is approximately 1.49997. Right, so almost 2. Okay, then if you wanted to try and do the work separately, all right, let's clear this out. And I just want a fraction. I could look to say, hey, 1 minus 1 over 3 if I wasn't certain about doing in the specific way, all over 1 minus 1 over 3. Oops, not 4 over 3. Let's correct that. 1 over 3. And I noticed that I get the same value. So you can do it in little parts, or you can do everything all at once. Important that we understand our formulas. Important that we know the formulas are provided for us, and they will be. Right? You'll have these formulas provided for you, but the more you understand them, the better you're going to do. Thank you for your time. We've got one more video left to do the last set of problems for the review set. Come back and see us.